Hello everyone, welcome to the seventh video for our playlist Civil Engineers, Jobs and Interview Questions. As we are discussing about the important points and helpful material for job interviews and exam questions for civil engineers. So this is the seventh part and our seventh video of our series. And in today's video, we are going to discuss three important points, or you can say three important questions. So the first point for today's discussion is that in soil filling, after doing soil filling and doing compaction, we need to take three samples. Three samples should be taken for core cutting test for every 100 meters square. For every 100 meters square area which is compacted, we need to take three samples. Got it? For every 100 meters square, we need to take three samples of the soil which have been core cutted. So the core cutter method is used for this. What is core cutter method? A core cutter method is a test used to determine the in situ dry density of the soil. So it is only used, the limitation of this test is that it is only used in fine grained cohesive soil, which the soil which is without stones. And another important point related to this test is that the test requires cylindrical core cutter about 130 millimeters long. These are dimensions of the cylinder which is used for core cutting. The dimensions are 130 millimeters long and 100 millimeters of the diameter. And yeah, and other point which I need to tell you is that I must tell you is that the bulk density of soil can be easily calculated using this core cutter method. So these were some important points related to the core cutter method. But the important point which we need to remember is that we need to take three samples of soil for the test, and this three sample is the limitation for an area of 100 meters square. So that's it. And the second point for today's discussion is that samples for fresh concrete shall be taken, and at least a set of 6 cubes of 150 mm shall be prepared and cured. 3 cubes each 7 days and 28 days shall be tested for compressive strength. What does this mean? This means that whenever we are required to do the compressive strength test of any concrete sample, we need to take 6 cubes. Total number of cubes should be 1, 2, 3, 4, 5, 6. There should be 6 cubes, and among these 6 cubes, 3 cubes will be tested at 7 days and remaining 3 will be tested at 28 days. Got it? So as we know that as the concrete and cement are always tested at both 7 days and 28 days for compressive strength, and the compressive strength at 7 days is known to be 65% of the final strength. The final strength which we achieve is at the 28th, after 28 days, right? So the compressive strength at 7 days is known to be 65% of final strength. What is the reason of doing double testing? Like we are doing the test of 3 cubes after 7 days and 3 cubes after 28 days. This double testing is done so that if the 7 days strength is found inappropriate, then the cubes may be discarded to save 28 days. Because if the results are inappropriate, then obviously we need to discard those cubes that will help us to save 21 more days to wait for this, wait to take out the strength after 28 days. Got it? So obviously the strength of the 28-day cubes will also be probably below our requirements. That's the reason. So what question arises here? The question arises here is that why don't we choose a time earlier than 7 days? If we want to save time, why we are not choosing the fifth day or a sixth day, because it will save more days. The reason is that because at that age the strength gained by the concrete is very steep and there is higher margin of errors. Got it? So since for both tests, for tests 7 days and 28 days, 3 cubes each are prepared. Hence a total of 6 cubes are prepared for the compressive test. So that is the main explanation for this point. So we need to prepare 6 cubes, and out of those 6 cubes, 3 cubes will be tested at 7 days, and remaining three will be tested at 28 days for compressive strength of fresh concrete. I hope you got it. So let's move to the next point and last point for today's discussion. And the last point is saying that the water used for both mixing and curing of concrete shall be clean and free from injurious amounts of oil, acids, alkalis, salts, sugar, and organic materials. Got it? So the water we are using for mixing of concrete or either for curing of concrete, that water should be free from various ingredients like oil, acid, alkali, salt, sugars, and organic matters or other substances that may be deleterious to concrete or steel. Got it? That's the point we need to remember. And the other point is that the pH of the water which we are using for the mixing and curing of concrete, the pH of that water shall be generally between 6 and 8. It should not be below 6 or it should not be above 8. So it should be somewhere between 6 and 8, 6 to 8. So that's it. That's it for today's video. We will end this video here, and in next video we will come up with more important points. So till then, goodbye. See you guys in next video.